Hello everyone, welcome to another interesting session of my project ideas. Today we are going to discuss about tail recursion. So here what we are going to do is we are going to have a brief outlook about what does tail recursion means. In the previous video we already saw what is recursion, how do we perform this recursion, what all things do we need when we are performing recursion, why is recursion faster, why iteration is not used. Here we are gonna move forward and we are gonna see tail recursion. What is tail recursion? A recursive function is said to be following tail recursion if it invokes itself at the end of the function. What does this mean? If there is a function and the function calls itself at the end of the function, then it's called a recursive function. Okay? So it's a bit complex, right? It's simple, guys. No need to make it complicated. If you have a function which calls itself at the end, it's called a tail recursion. That's it. Let's have a code. Let's write the code, then we'll get to know better. Let's see. So I've already created a file. Let's write def print n. This is the name of the function. I've taken a parameter n. Then we have the numbers like if n is double equal to 0, we have this conditional statement. We are gonna return, or else we are gonna print n. Okay. Let's do one thing here. Let's call it again. So you know what I said you, that here in the tail recursion what happens? The functions are called at the end. Okay. Now let's got it. Let's put the number 5. Let's save it. Run it now. What is the output? 5, 4, 3, 2, 1. What do we get here? I have not given a space. Yes, I haven't given the space. Let's run it again. You got 5, 4, 3, 2, 1. Got it? Now, let's see again what do we have. So you can see the output is 5, 4, 3, 2, 1. Which one is better? Question might pop up in your mind that which one is better, tail recursion or non-tail recursion? The tail recursions are better than non-tail recursions because the tail recursions are optimized by the compiler. They can be optimized by the compiler. Compiler is a when you're writing a code, the compiler compiles your code, then you get the output, right? So the compiler can optimize the tail recursion functions. So what's the idea? Because a recursive call is the last statement, there is nothing left to do in the current function. So the current function's stack memory is of no use. Got it? Because in the tail recursion, the recursion is at the end of the function. So after that, no other statements are there to compile. That's why there is nothing on the function stack frame. That's why it's optimized. It's optimizable. Can we write a non-recursive, non-tail recursive function as tail recursive to optimize it? Can we do it? Of course we can. Look at the examples. In the left box, you can see we have a function where we are calculating the factorial of a number. And on the right hand side, the same function has been written in such a way that it's tail recursive. It's optimized to tail recursion. So what have we done? We have just changed the parameters and the recursion is done via n-1 comma n multiplied by a, where a is a second parameter which is given by the function. You got it? So the factorial number. So what is the idea behind it? You are going to use one more argument like we have used here a, the number whose factorial is calculated is n. And in the second box, in the right hand side box, you can see a parameter a, which is basically used to accumulate the factorial value in the second argument. It's pretty simple. You understood the tail recursion concept. So I hope it's clear to you. Let's wind up this session for today. And for more interesting project ideas, stay tuned. And until then, do not forget to learn. Stay healthy, stay happy. I'll take you later. Bye-bye.